Hello and welcome. I'm Bill Wake. We're here working on the Swarm game. It's an old 80s, 1980s style basic game, and I'm using it as an exercise in kind of transliterating from one language to another, building up a little bit of runtime support, and then I want to refactor in the language. We had the game running at least at some level, or apparently the other day, but and I want to refactor that. But I think today I just want to focus on the infrastructure we have and fill in some gaps there. We well, this is a bonus session, I guess. Usually I don't do it on Friday, so I'll do something a little different today. All right, so let's. Well, let me skip forward a couple slides here. The game looks something like this. There's a ship. It moves horizontally. There's rows of stars that come at you, and you have to avoid the stars. Okay, so pretty simple concept. All right, let's get over to the IDE. Okay, so I don't think. Yeah, I'm not running. Okay, let me kick off a run while we look around. Okay, so our to-do we left off, we got the buttons working by sort of faking up the keyboard events. There's probably, well, I'm sure there's better ways to do what we did, but we got something. But what I wanted to, and okay, I mentioned this here, like restarting a for next loops. So I want to focus on stuff like down at that level. We got the go sub, the for next, random, peek, and poke, and they're all kind of low level things that go on, or I don't know how I want to say that. It's not that they're low level so much, but like for next and go sub and random, they have pretty complicated semantics. Really, I mean, I don't know. They shouldn't be as complicated as they are, but that's the way that's the way it was. So I want to fill in a few gaps on those, and then peek and poke are the memory map stuff for I/O and some other things, and we've done a little bit of that. I want to do some more, and I think that'll fill. I'm only going to be here for an hour and a half today, so we'll see what we get done on that. All right, but for next loops. Okay, so for next loops, let's see. How about should be? Well, let's just say can. Can restart. Okay, so if I'm in the middle of a for next loop, let me get to this the real code here. I mean, it's horrible to read, but see, here's line 95, and then somewhere down here, next NA. So the for loop runs from the for to the next NA, but basic is all about these individual lines. So you could have them kind of anywhere. You could have, whoops, line, this next NA could be up here somewhere, and as long as you arrange for a GOTO to bounce up there, so it's not a textual structure like in, say, practically every language you would use today. Swift or Java or C Sharp or any of these, that they delimit this thing textually. In Basic's case, especially these old ones, it's more like when do you see it? It's dynamic. So when you get to the line and you execute it, that's when it is. And so what can happen? It's a little bit complicated case here, but I think it shows up in this code. NA to next NA. Mostly this is a loop, but it goes subs, which means it goes to a subroutine and comes back. But this little bit here, if low, then 200, that means if low is not 0, go to 200. Okay. And it does some stuff and it prints some stuff. Then it goes backwards to 150. If greater than 0, then 95. Okay, so 95 is the for loop again. So we may have been in the middle of this for loop, and depending on what things look like, we ended up restarting it. Okay, and the semantics of that is a little complicated. And this is why when you say, GOTO is unstructured, this is the kind of thing they're talking about. You don't have kind of a single entrance, single exit, or even a single entrance kind of multi exits that go down to the same place, funnel down to the same returning. Um, this, it just kind of randomly decide. Well, it's not random, but it just decides like, oh, I think I'll jump up there and restart the loop. Okay. Even though you've got it going. Now the semantics of the loops, you actually kind of need a stack to manage them, or well, kind of implicit or explicit. But here we have for NA equals 1 to 10, and here's a loop on X. Well, here's a loop on A, but opens and closes. So when you say next A, you're going to go back to that one. X equals 1 to NA, whatever. Next X. Those are okay, but there's also this LW. Where did that start? 97. And so next LW, it tests if things are out of range, then it comes back here. And if they're in range, it wants to go to the nearest one. Now these nexts, they're being explicit about what variable is involved. And so we can know that this next is not the next for NA. It's got to be the one for LW. But in effect, you don't have to have those names. You can just use next by itself, and it's supposed to be able to recognize like, oh, I'm nested. The nearest nested one is this, and go from there. So the effect for us, we're basically managing a stack of for loop entries, but I think we'll be able to figure out a test that will demonstrate it. But the issue I see is this case where it jumps around and then jumps back to the start. Right now, start of a for loop just says push yourself on the stack. Well, 4KK is already on the stack. And so that means we could, in principle, keep stacking. And that's not a standard basic kind of thing. Basic is, it doesn't allow recursion. So, even their subroutines don't need to use the stack. And it definitely wouldn't, they definitely don't allow this kind of thing. They would restart the loop. They wouldn't they wouldn't take any other interpretation than that. Okay. They would not stack loops arbitrarily deep. Okay. And let's see, there's something else with that. Well, that's a little bit of a change to what we're doing, because right now we don't keep track of the variables on the stack. We just keep track of the names. And so a next that doesn't have a name, we wouldn't know what to do with it really. I don't know if we look at the X though. I don't know if we look at the variable either here in the next clause. All right, so that's probably the starting point. Another thing, I think our Go subs are okay. Our random is not really quite up to the job of theirs. The way the random number generator is, basically, if you call it with the same number, it's going to use the next element in that sequence for that number. So they're pseudo-random numbers. So if you give it the same number every time, you get the same pattern every time. And so if you call, like here we have R, we never change name. It starts out 84. We never change it. So we should get the every time you call it, you should get the next element out of the sequence that started with 84. We'll let that run. Okay. And so what we're doing instead is we're just calling give me a random number. Okay. Which is an improvement, because at one point it was just like give me 0.42 and we'll pretend it's random. But the semantics aren't quite right. And let's see. I've got that over here. Let's see if I can find a good window. Okay, yeah, here's the basic manual. This is from the 4K RAM Ohio Scientific computer with 8K basic and I think a 4K display area or something like that. You know, back when kilobytes cost you real money. Okay, did you open? Oh, there we go. Okay, so random is down here somewhere. Let's see. There's all the statements. Yeah, you know, I don't know. There are days. Okay. Random 0 always generates the same number. Okay. Random X with the same X generates the same sequence of numbers. Okay. So we need to get that. Um, we need to make our semantics conform just to be kosher. I'm sure there's a way to do it. All right. Now, what I'm imagining is we're going to special case 0 and just pick some number and return it. And if X, I think we'll have to monitor the argument coming in. If it's the same as last time, we just get the next sequence. If it's not the same, we use that as the seed, and then return the first item out of that sequence from the seed. Okay, and that way you'll get a consistent random number generator. Okay. So let's capture that semantics in my to do. Random 0 generates same number every time. Else number from, well, same sequence, something like that. Hopefully that gets us there. Okay. And what else? The peek and poke stuff. Oh boy, my brainstorm. That I'm making things hard for myself from a type point of view, and we saw some horrendous workarounds. Where was that? Is that in Swarm? Somewhere we have a little helper function that's like convert this, convert that, convert this, convert that. After 3 or 4 things, you get to the character you're after. Would that be in content? Content view? Yeah, this thing. A string of character of Unicode scalar of int of value. You're right. Okay. That's horrendous. Maybe it's the only way to do it. But part of the thing I think is going on, we got our memory array. Let's see. That's in Swarm. All right. So the memory array is there it is, screen. Okay, notice its type is int. Well, this is a 1980s era microcomputer. Int these things are not ints, they're bytes. Okay, so I think maybe we should make this uint 8, and yeah. And even then, I have my suspicions that this conversion is not, well, somewhere we talk about UTF-8. So I don't know, back down in here, when we're doing the peaks. Okay. No, it's the pokes. Well, I don't know where that is. Here it is. Print. Yeah. So basically this thing of converting stuff to show up on the screen, we're taking the characters, converting them to UTF-8. Well, that's not really accurate if they're really just bytes. Okay. and it means that probably some of our upper bit bytes would be screwed up when you converted them. So I know this is not adequate. So let me capture the note on that. Print needs to handle bytes, not UTF-8. Okay. And let me put this on chat. That's what it's there for. Okay. And one peek over here. Okay. So I think if we can get through one or more of those things, that'd be a good step. This one, I think, because it's in our code that it needs to handle this, I think our code is probably just creating a big stack, and it just doesn't run long enough to blow up. This is not a 4K machine. This is a 16 gig machine or something like that, 8 or 16 anyway. And it's just not going to happen. So let's look at our code for for loops. Okay, so the translation we did, I mean, for a for loop, let's find one. Excuse me. So here's next loop. So next LW, I translated to next loop call. And so the idea is this next loop, this is kind of generic basic support. Any transliteration I did from, for another program would probably just do the same call to next loop. The variable matters, the line number matters, but those are parameters here. Okay, so, and then for is just a for loop. There it is. For loop. It knows the variable, the start, the end, skip, and the address of the next statement, the loop body. Okay, so where do you loop to? In this case, it falls down through. Okay, and the code for that. Okay, so here's for loop. So it appends, and notice it uses the variable. So if you're a for loop variable, we keep you in a map. I couldn't find a good way to get the reflection to let me just point to the variable that's sitting in my file here. So we use the map to initialize the variable to the start value, which is an honorable thing and the right thing to do. We also have appended it to the loop stack, and the loop stack, we're just putting this little tuple. What's the ending amount? What's the skip amount? Usually it defaults to 1. And what's the statement that starts the loop body? Okay. And then the next loop, it makes sure that we're not calling next without having called a for loop first. So if our program started out 10, next X, it'd be like, I don't know what you're talking about. You don't have a for loop going. Okay. So this catches that. Now, if the variable is there, okay, we pretty much know it will be. I mean, if we've generated code properly, the variable will be there. So I'm using that to justify this exclamation point. Look up the variable, add the skip amount. If it's less than or equal to the ending, then we're going to go back up to the top of the loop. That's the loop, this loop target, loop address. If it's not less than or equal to the ending, then we're going to pop the loop off the stack and go to the exit point for the loop. Okay, so the next X, that statement, whatever follows that, either on the same line or a different line, is the where we go after the loop ends. Okay, and so in this case, loop stack remove last, that is fine. But the case I'm worried about is, it would be legitimate to call for loop with the variable X, and then call for loop with the variable Y. That just means we've got a nested for loop, X outside of Y. But if we then called for loop of X again, nothing in here is going to know there's a problem. Okay, so let's make a test. And I don't know, maybe these are more like basic tests, basic support tests. And I think they're all that, right? At least, yeah. So let's rename this. Okay, so let's make something happen. Rename. Okay, so I'm going to say basic support tests. And where I'm headed is I'd like to separate out the basic support from the generated or transliterated code. So I'd like you to be able to just like, if you systematically create this loop or this switch statement or something like that, then we will be good. Okay. Everything else will be there to support you. Okay. So for loop sets initial value. Next increments the value. It can increment twice. It doesn't repeat if it's past its value. And then we get into the nexts. Well, let's set up a situation for how about start for loop and go to loop. What do I want to say it does? It restarts the loop. Okay. And this will be an interesting one. Okay, and I'll take this much from the test before. Create the variable. Let's say NA. Okay, and I just mix up things here. 1 ends at 3, skips by 2. So this is 1 less, start at 1 less than or equal to 3, skipping by 2. So we should be able to do a next loop. Okay, exit 9099. Right, now we know that because the next works, we know that we should be going back to the top of the loop. Okay, and not getting rid of it. Okay, now we're gonna do a GOTO. I don't know if I have completions. GOTO. I don't know if I need the GOTO. I guess if I did the GOTO, what happens? Well, I get my for loop again. Okay, so we're abstracting away all the intermediate stuff, and actually maybe this is even unnecessary. Let's try it without that. So I'm saying you start a for loop, and now you restart the same for loop, and how do I want to determine this? Okay, if I do the next loop on it, all right, so let's start at 1, end at 2, and we'll skip 3 just to be very clear that we're going to be beyond it. Okay, so the first time through the loop is fine. When it does the next and attempts to skip 3, it says 1 plus 3 is 4. Is that less than or equal to 2? No. Well, pop the loop and go to the exit. Okay, so it properly goes to its exit. Right, now if I were to do another next loop, so if I sort of pretended my loop is nested and tried to execute the next loop again, right? Now the loop should be off the stack. Okay, so let's do NA. I don't know if I'm being too obscure, but all right. This should be illegal. Okay, so the setup is we go to the same loop twice. I don't even know if we need... Yeah, we need the first next loop, so we pop. Okay, and then when we do this one, now we should be back in this situation next without for reporting errors. So I expect an error. Well, let's check our setup first. At this point, I expect swarm.error to be empty. Okay, and then after this thing happens, I expect it to be this. And I guess this line is true as well. 0 forces an exit. Okay, so I know that this is a bit of an odd test because it definitely is a corner case, but we have it in our code from a sample drawn from the wild. Okay, so start a for loop, restart the same loop, call exit or next loop, which will exit the loop, and we expect to be in a non-error state. And then when you call next loop again, we should get an error that you don't have any loop left. You've already exited the inner loop, and this one should have been repurposed, So I believe this test is going to fail. I probably should run them all, but we'll get there. Okay. And I'm really bad on these small commits. I should have committed the rename there. Now the downside of this is I think this is kind of confusing. I can probably come up with a better name for this. Maybe I should think about that. So this, I think what this case really is you can't nest. You can't nest a loop within itself, or you can't nest a loop with the same name. So I can't go for NA equals 1, then next line for NA equals 2, whatever. It looks okay at the moment you did the second line, but that really shouldn't work. It doesn't mean anything. Now I don't know that you have to detect. It's not an error. That's the funny thing. It's really just saying restart the loop. Okay, how are we doing here? Not so good. Oh, so slow. I keep forgetting I should turn this debugger off by default. Okay, so if I do this, it will run faster next time. Okay, yeah, so we did not get the message. We did not go to the proper line number. Now, I think what I want to do, let's give this a better name. So, can't nest loop with same control variable. All right, I think that's more like it. I'm gonna mix these up a little, just so we're definitely able to distinguish them. Okay, so this is like writing for NA equals 1 to 2, skip 3. For NA equals 2 to 4, skip 10. next NA, next NA. But it's not, we have to do it dynamically because that's the way the basic interpreter does it. So that's the way it goes. Okay, this one exit 999, and let's let this one exit 1000. Okay, so everybody's different. Notice usually I do arrange, act, and assert. This time I'm doing a bit of a setup assert. I just want to be very sure that I'm doing what I think I'm doing. Okay. None of these are the same, so we can distinguish them if we have to. All right, I'm going to run all tests. Okay. Somewhere I turned on notifications without meaning to. Okay, should fail for the same reason. And let's think about what we're going to do. Well, I kind of gave it away earlier, right? We need to know when we go back on the stack, when we're starting a loop and go back on the stack, is that variable already on the loop, already on the stack? Where'd my tests go? Basic support tests. Okay. So we need to know that the same variable is being reused. All right. So that tells me my stack needs to know that too. All right. So let's change this one. Our stack. And even the fact, I noticed this again, like the fact that I'm scrolling up, way up to get to it, it's telling me like, hey, these are probably different classes. And I know they are because one is my game I'm trying to run, and the other is my interpreter that I'm trying to run. It's interpreter support. Okay, but here's loop stack. Let's put its variable in there of type string. Okay, that's these loop variables. Okay, and we should get some completes. Yes. Okay, I'm saying, hey, you need to tell me what the variable is. Variable. And same thing here. How about we call it stack variable, since we're not looking at it. It's different than the one, we're saying next X here. This is the for loops variable. Okay. All right. Yeah, that's okay for now. Okay. The test should fail. We haven't done anything. All right. So now I've got the variable in there. All right. So it really comes down to the next statement. It's going to have to do all the work. It really needs to say, well, let's see. Loop start, loop append. No, maybe we do need to do it here. If this thing is in the stack already, we need to remove it. Okay, now I don't know if there's a good way to do that. And this may be, I just don't know. Let's see. Well, okay, so we have this loop stack, and we would like to know if there is somebody who already has variable, we want to remove them from the stack. And if nobody does, then that's fine. We're just a new variable and we can go ahead. Okay, so let's take loop stack. Oops. Loop stack dot. And then I think we need to do a find or a search of some sort. Remove at. We don't know where it is yet. first where? First index where? That's probably more like it. Okay. And then the where here is, well, let's do it like this. Because this is a functional argument, we can just put the stuff inside braces. Okay, but the where is that thing? Okay, there we go. Okay, so we need to say, I think we can say it like this, variable ending, well, let's do it. Stacked variable ending, no, stack ending. Let's see. We don't care what it is. I don't know. Can I say, let's try this. Can I say $0 dot stacked? No. Because $0 is going to be this variable, this tuple. Okay, so I guess it's going to make me do this. Okay, so I'm going to say, I'm going to keep it straight with stack ending, stacked skip, stack loop. Okay, in. All right, and we want something that returns a Boolean. Look at that stuff and do a decision. We want to say variable equals stacked variable. Is that going to work? Is it just that it doesn't used? Okay. So if we get the first index, okay, let existing, or what do we call that thing? All right, we'll get a name in there. Existing loop index equals this. Okay. If existing loop index is not null, that means we found it. Okay. And, oh yeah, I don't need these others, probably. Nil. Okay, so this returned an optional. We can see that here. Returns an index optional. Okay. Then I think if it exists, then we want to remove it. Loop stack dot remove at, and hopefully it accepts existing loop index bang. Okay, we know it's not nil, so it should be safe. Ay. Okay. And then I think these, we're not looking at them, so we can just say we don't care what they are. Okay, so we're going to go through our stack, find something with the same variable as the one we're about to make a for loop for, and if it exists, remove it. It's I don't know. There may be a better way to do it. Let's see is this going to work. Well, yeah, I think all those could replace. Do we care what stack variable is? Not really at this point. It's more for the for loop. Okay. I'd like to say it's going to pass. But my record when I take 10 minutes to do it is not as good as when I take 1 minute. Okay, well, I feel good about that. Let's make that test case a little more obnoxious. And I just want to be extra careful with it. All right, let's make another loop. SC. Okay, just to pick something. I don't care where it starts and ends. I guess let's do 2. Again, I'm just mixing things up. 3, 4. Okay, so I'm creating NA for NA equals 1 to 2, for SC equals 2 to something, for NA equals 2 to 4. The next loop on this NA should exit. The next loop on SC should exit. Um, 998. Okay, we'll exit there. Doing those two should not be an error because those two should be the 2 active loops at this point. When NA was fine was the top loop, but when that came in again, it got removed. Okay, so we're going to exit both those loops and then go back and make sure that if you do another next, NA is not, there's no third NA on the stack. Okay, I believe this should still pass. Well, for all I said making that scheme different would speed up the testing like crazy, it doesn't seem to be doing that, does it? Okay. All right, so I think it's a complicated and corner case, but I think we've done it. So for loops can't nest with same index variable. Okay. I think that is what we wanted to do here. Okay, so this is the 9th. I think that's an accurate thing of what we're saying. Okay. I want to move this one up and pick up there next. But we've been going for a while, so let's take a break, like 3 minutes, and we'll come back, and I think we'll switch the screen to work with bytes instead and see how that goes. All right. See you in 2 or 3 minutes. All right, welcome back. So let's see. So print needs to handle bytes. Well, I think it's really the screen needs to handle bytes. Okay. And let's see what we got here. So, did I check in? Yes, good. All right. So our basic support. Well, I think that'll be affected, but we're just going to change this type and see how that goes. Now, I don't even know, does Swift have a byte type? Screen, let's make this byte. Does that work? No. uint 8, unsigned 8-bit integer. That sounds about right. Okay. uint 8 to int. Okay. So we're going to pre-fill it with spaces, and the count's not changing. Now somebody should be caring. Let's see who that is. Okay. So now anybody who deals with memory, they need to be returning uint 8s. 8. Okay. Cannot convert expression. Return it with uint 8. Yeah, I think that's all right. Okay, same thing here. Address the value should be a uint 8. Cannot assign to poke. Okay. Replace the value with int value. Keyboard poke. You know, I think it's telling us we need keyboard poke needs to be 8 uint 8 as well. Okay. Yeah, now we find who else is affected. I think we're going to make our poke accept int. Let's go back to int. And then this is going to, we'll force assignments to do this. Yeah. I think that's actually going to be better semantics for us. No exact matches of calls. Spring append contents of characters. Okay, yeah, this is the one that's really messed up. Okay. Oh, what do we have up here? Let's deal with that if it's easy. Peak. Ooh, maybe peak needs to return. Okay, let's make it back to int. This probably needs a cast. Binary and cannot be applied to mix types. Keyboard poke. Well, this is back to that. Keyboard poke. Let's turn this. Like that. Okay, and then down here. Okay, so screen line. Oh boy. So yeah, the challenge is we're in these domains, and like Swift thinks string should be Unicode, and no, that's so easy and great. and you're printing a string, but our memory thing does not like that, right? When we try and put it in the screen, it 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 doesn't know what to do with it. It thinks we should have um, an array of int eights. Let's see what we got. Okay, we have an array of ints, well, a subsequence of array of ints, and this it says screen append. Screen holds uint eights, so this is just not legit. Okay, but I think the seed of correctness is actually in here, and I think that's this bit. If you take the Unicode scalar value of an int, then that's if it's 255 or less. I think. Let's see what Unicode scalar does. Let's get another window out here. Represents a single value instance. Okay, you can init it with a uint8. That's a good thing. Okay. So we can get from the screen to Unicode values if we want to. Is that what applies here? Okay, this is a bunch of ints. Well, I don't like the UTF-8. Let's take a peek at that. Swift string. Yeah, it's a UTF encoding. So what happens when we have, I don't know, if we get some weird character, some Unicode character that's not ASCII. I don't want it converted into multiple bytes. That's just not what this is supposed to be. So let's see what we got. Screen line. And what Unicode scalar of character? Okay, what was this thing doing? Unicode scalar of int of value. So can I do that? So screen line int of, what's that type? No exact matches. $0. Thanks. Screen line is a string. When you iterate over it, what do you get? And this gets very messy with, okay, here's is ASCII. See, that's more like something we might need. But my question is for string. Are you on here? And it's string. A string that's a bunch of those. Accessing string elements. So, yeah, these things are multiple values. Extended graphing clusters are represented by character. So character is not a byte by any stretch. Okay, so what are we doing? We got a bunch of characters. We got a string. And when we do a map, I think let's try this. Foo in int of foo. And what's the type of foo? Okay, let's just string element. Let's go back to Unicode Scalar. It's the element type of a Unicode Scalar collection. It's a string literal that contains a single character representing exactly one Unicode Scalar value. Oh. Well, the crazy thing is here, I just want to get the ASCII value of this character. Okay, so you give me this string element. Okay, and let's see what characters comes out as. It's an array of strings. Okay, but if you were to give me hey, we've got a game that's in BASIC. Let's see, it's up. Here's the BASIC version. This is an old BASIC, 1980s era. Okay, and what I wanted to do is translate it into Swift kind of by hand and then modernize it. What we're in the middle of, we've already transliterated it, which I'll show you in a second, and we're trying to get stuff like for loops and peeks and pokes and screen stuff working on it. It works at some level, but I want to refine the types. I used ints and strings all over the place, and I want to get down to bytes. So what happens is basically each line of code in the original gets turned into an equivalent Swift line. I manually looked at it and said, oh, SC is an integer, so let's make a variable for it up here. And when you say SC equals 0, we'll assign it. When you do these, we'll assign them. I put in go-tos wherever they go to. Here's a poke. Well, let's have a support routine poke. Here's a for loop that does a bunch of prints. All right, we can manually translate that. Here's a for loop that's more complicated. Well, we're going to have a subroutine that helps. And so each line is, it's either doing stuff directly or it's calling one of these little helper subroutines. And when you do that, I think it should run for us. So let's see if we can get it to run. But anyway, we've got enough support going. Oh, I've messed it up now. It's not going to work. I'm in the middle of this change. So this change I'm trying to do is we had our screen memory was treated as integers originally. I want to treat it as 8-bit bytes because that's all those old computers had was bytes. And this part is a bit messy. When you say print a string, I need to convert it into those bytes. And so that's kind of where I'm getting balled up a little bit. I've got the characters. Each one of these is now a string element, which I think is basically a character. I don't know if I can I just call character of element? And I don't know. I've been dabbling in Swift for a while, but I'm definitely not an expert. You can probably tell. But like this thing, we've got a string element. I don't know. Can we see what that type is? Maybe that'll tell us something. So anyway, I'm trying to convert strings that you would pass in to a print statement into character bytes on a screen, and the another challenge we have with this is the ASCII ones, A, B, C, D, and so on, are easy, but then you have all these little graphic characters that they used to use before Unicode came along and all that. This is back a ways, and so like little balls and airplanes and little bendy lines and stuff like that, things you could make little games out of, basically. And so we've got to map them into that byte level, then we got to map them back out on the way out to show the shapes we want. We're cheating on the shapes now. I just use regular characters for now, but that's kind of where we are. So let's see. Swift.string element is probably just like your string is built out of elements, I suspect. It's like a helper type, I'm guessing. Substring. Class string. Not finding it. Okay. Well, documentation maybe. Well, what's that? Raw value. I don't know. Can we get this raw value? Where's that used? Let overlay class. It doesn't sound like what we want, does it? Okay, well, let's get back here. All right, so what I have is an ASCII character. I guess if value is an int, if I call Unicode scalar, well, I can initialize it with an int 8. Instantiates an instance of the conforming type from a string representation. Okay, is that... So, I think this... Is that going to do something? So I'm pushing the character back into a string, and now I'm getting the Unicode scalar version of it. Whoops. It's an array of optional Unicode scalars. We know they're going to be legit values because they're always, well, we're presuming that for now anyway. All right, so maybe I can pull the rest of this. If I turn it into a character, I guess the question is, can I go back to a byte? Can I do this? No exact matches on call to initializer. Well, I don't think I can do this. Okay, so I should have everything should be array of uint8. Contents of should get a bunch of uint8s out. Let's see if the test pass. Can't build. Okay. That's our 2-character method. All right, I think we're saying we're giving you a uint8. And that should be okay. It might be more complicated than we need to at this point, but let's see it work. So slow. All right, test running. A lot of startup time for this simulator. Okay, who's not happy? Crashed. Ugh. Okay. So the crash, let's see. So I've turned off the debugger because it runs tests faster without it. But when you want to debug something, you got to do it. All right. So my working theory is one of those exclamation points I put in on Unicode Scalar. It's probably coming back not convertible or something and blew up. Oh, so hard to get between the string type and other types. I mean, if you're doing actual string work in a modern language, you love it, I'm sure. But when you're trying to get down to the bytes and figure it out, ugh. And maybe I should ask that way. Convert string to bytes. Okay. They are going off the UTF-8. Name UTF-8. Well, maybe that's just what we got to do. Okay, so let's unexpected nil with an optional. Okay, let's try this other approach there. So we've got a string. We take .utf8 screen line .utf8 and then we cast it to uint8 or construct it, I guess. That will be our characters. Let's work this out. Yeah, I guess it is unused. I'm using a copy. Okay. Oof. Let's get rid of that junk. Screen line, append stuff. Okay, so we take whatever string you give us. We've got to have a prefix, your string, and then a bunch of blanks to match up to the rest of the screen line, and then we append them onto it, and basically we'll truncate. All right, now let me try running. Nice to claim it works, but your test can be wrong. All right, we'll hit go. Okay, there's my ship and my stars. I can move. I can move the other way. Okay, we don't have the keyboard thing working very well, so these buttons just map in. I'm just gonna let this run and it'll crash eventually. Boom. Okay. Score 480 waves 1. Okay, that looks a little funny to me, but okay. And the trailing is sort of like the exhaust from the ship, I guess. Okay, boom. Yeah. All right. So, I mean, it's okay. There's definitely something off, but let's capture this first. So, make the screen hold uint 8 instead of int. Okay, so I don't care about the space really. I mean, it's so irrelevant at the sizes we're talking about. But yeah. So what's going on here? Oh, let's go back. I don't know if I've got the old code still. No, I have to go back further. We chopped off the line length. All right. Clearly, our test does not check that. So let's get our test again. So I want to make sure print truncates the line. Truncates its output. Okay. So, I guess I want to see, we're just going to say print anything. Should be capital. Screen.count and assert equals swarm.screen.count should be original size. Okay, so the screen is a fixed size square, so if you print stuff to it, it should not grow. And I'm pretty sure it's growing. And our code a few versions back had something to make this. Let's see, do I have? let's see this. Swarm. Right, down here we did this. So I think we need to do the same deal. Our test should be just this one failing. Yes. 769. So it grew by 8 characters. Yeah. And that's the 8 characters we printed. So it just appended something somewhere. It's kind of a low-level test. But let's let characters to print equals this stuff. Prefix that and this chop. That should be chopped, I think. Okay, so we're only letting our new line be equal to the screen line distance. And I think we'll find that's making it okay. Okay. That is good. Okay, so make screen keep the same size even while printing. Okay, let's go back to do. So I think we've done that. Everything's in bytes now. All right, and we just have about 10 minutes left, but I think we can at least do part of this. The random generator should generate the same number every time if you give it a 0. We don't check that. So let's check that. Random of 0 is constant. Okay. I guess it needs swarm. Random of 0. Okay, so if you feed it 0, 0 is special. It should always return the same value. We don't even care what it is. We just care that it's the same. All right. And I expect this to fail because the way it does now, we just return the same value every time. So I call this infrastructure day because we're doing all this stuff down on the bottom. Next time, I'm hoping I have time Monday to run a session. I think I will. And, yep, that failed as we expected. 2 different random numbers. Okay. What I want to do next time is start diving in on the basic program and push it into some sort of structured form and start refactoring it basically. Yeah, I think that'll be a good exercise next time. But anyway, random. Okay, so in this case, if value equals 0, we're just going to return a constant, and I'm picking that one just because. Okay, or maybe pi would be more fun. 314159, a little bit of pi. Okay, I think the test will pass. While that's running, I'm going to look up how to seed a random number generator in Swift. Okay, set a seed, yeah. I don't know, how are we getting our random numbers? Float.random. Oh, we got to use the generator. Okay, interesting. Float random in using generator. Okay. Next test. With the same number, uses sequence, or return same sequence. Okay, so I think okay, let's take a different number, 40, 40. Okay. Let spoiler equals swarm.rand of 20. And let's make this R1A, R1B, R2A equals swarm.rand of 40, and R2B equals swarm.rand of 40. Wow, that's a lot of setup. I guess I can let that be. Okay, now I expect R1A to equal R1B, and R1A to equal R2A, R1B to equal R2B. Okay, so I'm running a sequence on this. I switch to a different number. If I come back to my sequence on that, I'm effectively starting a new sequence, and I should get the same sequence. Okay, so R1A, R1B should equal R2A, R2B. This is not going to pass. And I think the solution we're going to do, okay, yeah, just totally random numbers. Okay, the solution I'm going to do is I'm going to store the seed, and if the seed changes, then I have to regenerate the seed. Okay, let's see. So now we need a stored seed. How about last random seed? We'll start at 0. And then our random function. Okay. Do I still have that thing around? No. If value is equal to the last random seed, then we're just going to get it. Well, maybe I should say it the other way around. If it's not equal to the last random seed, we need to do something. And what we need to do is this. Generator equals that. Well, random number generator with seed. Ooh, is that something they made up? Oh, I don't. Okay, that's more than I want to do. SRAN to 48. Well, jeepers. DRAN 48. DRAN 48 returns a random double. Okay, so maybe that's what we want to do. Last random seed. Okay, otherwise we're going to return DRAN 48. DRAN returns a random double. Okay. Okay, we'll cast it to float. Is that allowed? Okay. All right, well, pass or fail. We're going to stop here. I guess if it passes, I'll check in. That's the only difference. So what I expect this is doing is it's going to restart the seed. Yeah. So because the first time through the 40, it's new. It restarts the seed and then returns a value. The next time through 40, it doesn't restart. It just returns the next value. And then we did 20, and so it resets the seed and returns something. And then 40 resets the seed and returns the other value. So it does seem to be working the way I want. So let's see. We made random meet spec 0 returns a constant. Anything else comes from the sequence for that number. All right. So as I said, next time we will start refactoring. I think we'll be doing low-level stuff, kind of cleaning up the structured code